Hello. In the previous video, we created our triangle base class. So now we're going to move on to our abstract class called Shape3D. And what's so special about Shape3D other than being a base class? There's really not too much of a difference between a normal base class as well as an abstract class. Well, in terms of like what's actually being typed, that difference is small. However, this small difference has a lot of implications, mainly the fact that, well, as you'll come to see in just a little bit, while our triangle based class is quite usable, our abstract class here, Shape3D, is not exactly going to be usable. I mean, in the sense that it's not going to have a lot of utility. And actually, so we're finishing up the constructors here. And it not having utility, well, we'll find out. I'll show you why later, when we finish all the methods for this base class. So of course, since it's going to be a base class, I need to make the destructor virtual. And now, so Shape3D only has 3 attributes: depth, surface area, and volume. And I chose these 3 attributes just because this is what I think of when I think of a 3D shape. I mean, of course, accounting for the attributes that's already in triangle, right? If Shape3D is going to be a 3-dimensional complement for triangle, well, I need to fill in and add the things that I need and the attributes that I need to let a 3-dimensional shape that a class can represent come to life, right? And so far, I mean, all of this seems okay. All of this seems applicable, right? This doesn't look too different from having our triangle base class. The biggest difference is actually going to come at this line. We're going to have calculate surface area. It's going to be a virtual method, but I'm going to do this. I'm going to say this is going to be equal to 0. So what does this mean? This is the small difference, which is actually a big difference, of a abstract base class and a base class. So everything here from Shape3D, the 3 constructors, the destructor, my getters, up until line 16 set depth, I have to define all these. The virtual methods on line 17 and line 18 here, these are called pure virtual methods. So what does this mean? Well, this means I don't have to define them in Shape3D. I can say, you know what, the class that inherits from Shape3D will need to define these. I'm going to leave it to them. But wait, if you're leaving the surface area and the volume calculations to the derived classes, well, what happens with Shape3D? Well, Shape3D doesn't exactly have that much usability in terms of being a general Shape3D. Again, because when I think of a 3D shape, it's going to have 3 attributes to represent the 3 dimensions it's representing as a shape. And here, this one only has 1, right? We may have our constructors and our destructors, but I'm not overloading any operators. My setters for surface area and volume, they're pure virtual functions. So Shape3D is in a weird area where I will need it as a base class so I can inherit this kind of stuff from it. And I can combine it with my triangle class to create our pyramid, which is going to be our 3-dimensional representation of triangle. However, Shape3D isn't useful by itself. So when I go and define Shape3D, well, you'll come to see that it's not really useful. It's more of just of a general declaration. And that's the role that an abstract class plays. It's usually an abstract base class where it has no utility on its own. It's not very useful. But however, as a base class, it can provide a lot of information and alleviate other classes of doing heavy work. So now that we have the header file declaration, why don't we work on, I need to rename it from capital Shape3D just to Shape3D.hpp. Now we'll do Shape3D .cpp. Of course, we'll need to include our shape3d.hpp. And then we'll go along with our constructors, as well as our destructor, as well as our three getters for our three attributes: depth, surface area, and volume. And finally, we'll focus on our setter, set depth. Now that we have our setter set depth, I'm actually not going to go forward and define my methods for calculate volume and calculate surface area, because they are pure virtual functions. With that, we actually have finished our base class Shape3D. And in the next video, concluding our trilogy, we are going to create our pyramid class, which is going to inherit from Shape3D, which we just created, as well as triangle. And again, to kind of beat this into your head, Shape3D is an abstract class, and it doesn't have that much utility. We can't really use it inside of a program, unlike we can with triangle. We can kind of look at Shape3D as some necessary code to act as an add-on, so that way we can add it onto triangle as a class and use both of it to create our pyramid class. And this is typically the norm with these abstract classes, is that they don't have that much utility in terms of being a class by itself. But I mean, in this case, our objective for this abstract class is to take a Shape2D class like triangle or even rectangle and use that class as well as this to create a three-dimensional class. And if I could, because Shape3D is so abstract, I can actually use it for creating cube and making it easier in creating cube. And that's really the role of these abstract classes, is that they serve as an important piece for the derived class just to make things easier. I mean, this just has a lot of backbone code. I mean, whether you need to have an abstract class or just a normal functioning class is a little bit difficult. But my general recommendation is that you create an abstract class to supplement and support a derived class that can inherit from a normal class, right? So with triangle, rather than going and creating a lot of the code from pyramid from scratch, if I have triangle and rectangle as shapes, and my objective is to take those two classes and turn them into three-dimensional shapes, it might be worthwhile to create Shape3D, so that way cube can inherit from rectangle in Shape3D, as well as pyramid inherit from triangle in Shape3D. Anyways, we'll put this abstract class to use when we create pyramid, so I'll see you for that video.